Hey everyone, I'm Vishal and welcome back to my YouTube channel. Today in this video, I'm going to walk you through the project I built to process unstructured PDF documents in order to extract the meaningful information and store it in a structured data tables in a gold layer by using AI parsed document function in Databricks. Before that, let me ask you one question. Have you used AI parsed document function before? Because our entire project is revolved around this function, and if not, don't worry, I'm going to explain this function in detail, what it does, how it works, step by step. And believe me when I say this, at the end of this video you are going to use this function on every unstructured document you have. So let's begin. Now, imagine this, you are working for an insurance company. Let's call it a safeguard insurance. And on a daily basis, you receive around hundreds of different types of claim documents. It could be property damage claims, health or medical insurance claims, and automobile claims. As humans, when we take a look at these documents, we could see it has some kind of a structure. For example, if we look at this property damage claim document that we have, we can see policy type, claim ID at the top, we see claimant information. Below that, we see some breakdown. Then we have a total claim amount and the claim status. Also, we can identify similar structure for remaining two types of claims, that is health claims and automobile claims. For us, understanding this document is easy, but for machines, it just sees it as a raw content. And this is where things get interesting when we use AI parsed document functions to process these PDF documents. So, what it does is instead of treating this entire document as a raw plain content, it simply breaks this entire document into different structure element, or we can call it sequential elements. For example, let's take a look at how AI parsed document function breaks this entire document, that is property claims document that we have, into structured elements or the sequential elements. As you can see on screen, the elements are highlighted with the yellow box and blue box. Now here is another interesting thing. Every element has ID, content, type, b box and description. Okay, so these are the fields that every element that which we can identify using this blue box and the yellow box. If we look at this first element, it has information, that is company's name, safeguard insurance co dot. So this is the content, and then we have a type which identifies which type of content it is, whether it's a title or section header or a table or a plain text. Then we have a bounding box, that is b box, which saves the information like where exactly this particular content is stored on this document. And and finally we have a description. This is AI generated description that AI pass document going to generate, and most of the times I found it is null. So we for now we are going to ignore this. So now instead of reading the document, we are going to work with the structured building block of that document, and I hope you are with me on this. So let's move ahead. So until now we understood how AI pass document function is going to break that entire document into these structured elements or sequence of elements. And now what we are going to do is we are going to extract the required information from that elements. And for this particular project, we are going to extract the information like breakdowns that we have for all three types of claims documents that we have. And then we are going to fetch total claim amounts and the claim status. Okay, after extracting this required information, we are going to store that in a structured data table in the gold layer. And next comes the best part. On top of that stored data table, we are going to use Genie, AI assistant in Databricks, to interact with that data table in a simple plain English. Let's say the question like, hey, how many claims are pending? So what we get in return, we get the answer instantly. And this is how our overall project is going to look like. If I have to summarize all of it, it's going to be like this. So what we are doing, we are going to process the PDF documents that we have for different claim types using app as document function. What we get elements, right? From that elements we are going to extract the required information. In our case, for this particular project, we are going to extract the breakdowns, total claim amount, and the claim status. And finally we are going to store that data in the delta table in the gold layer. And on top of that delta table, we are going to use Genie AI assistant in order to interact with the data that we have in the delta table in a simple plain English. And I'm really excited to build this project. So let's start with the actual implementation of this project. For the implementation of this project, I'm going to use Databricks Free Edition. And here the first thing we are going to do, we are going to create a folder for this particular project. So in order to do that, let's go to the workspace. Here we'll get an option to create a folder. Simply click on this create and folder, give it a name, safeguard insurance, and click on create. It will create a folder for you. Okay, in this particular folder, we are going to store our notebook. So let's click on notebook. Yeah, simply rename this notebook safeguard insurance document parser. So the next thing we are going to create is a Unity catalog, and in which we are going to create a volume in which we are going to store our raw data. So let's create a Unity catalog first. For this, I'm going to use a magic command SQL, so that we can write a SQL query in order to create a catalog. So I'll say create catalog if not exist. Okay, and we are going to give a catalog name as safeguard insurance. Okay, let's run this cell. Okay, on the left hand side you will see the catalogs that we have. This is the uh, default catalogs workspace and the system, and these are the catalogs that I have created previously. So our catalog is ready. Let's refresh this. Yeah, we have a safeguard insurance catalog in which we have a default schema and the information schema. If we select the default schema, we have nothing in the default schema. So we are going to make a use of a default schema in order to create a volume in it. So let's create a volume first. Similar to the above catalog, I'm going to create a volume using a SQL query. So I'll say create volume if not exist. So I'm going to give a volume path where I want to create the volume. So we want to create a volume in a safeguard insurance catalog inside default schema, and I'm going to give a volume name as a raw data. Okay, where we are going to keep our document files that we have for our project. So let's run this query cell. It's run successfully. Let's refresh it. In default schema we have a raw data volume. Now the next thing we need to do, we need to upload the documents that we have for this particular project inside the volume. So right click on this three dots and go to open in catalog explorer. It will redirect you to the catalog where you'll get an option to upload to this volume. Here you'll see we have an option upload to this volume. Okay. In your case, I have provided the GitHub repo link in the description. So check that link where you will find the data folder in which I have kept all the documents files that I have used for this particular project. So go there and download those files and upload the files into the volume. So I'll quickly do that. Meanwhile, you can go check out the link and download the data. So we have around 50 PDF files for all three types of claim documents. It's simply validated if we have some any files with the similar names. In order to avoid conflict, it simply scans the file names, and let's click on upload. Yeah, it is starting uploading the documents into the volume. As you can see on screen, we have uploaded all 50 files successfully into the volume. Okay, so let's cross check one of the documents that we have, and it looks good. So we done with the uploading our raw data into the volume. Okay, so let's get back to our notebook. Okay, so first thing I'm going to do here, let me go back to the raw data volume or low volume. So here you see the path where our raw data lies, right? So simply copy that path and save that path in a variable. So I'll say base path as this. Okay, run this cell. First, let's see if we are able to locate the files present in that volume. So for that, I'm going to use the dbutils command. I'll say dbutils fs.ls, and I'm going to give a base path. So I'm going to save this in files and simply say display files. We got the path, name of the file, size, and modification time. So we have around all 50 files we are successfully able to locate. So next thing we are need to do, we need to read these files content, right? So as we know that our data is in a PDF format and not in a regular CSV or Excel or JSON data. So it's going to be a binary form. It's going to be in a binary format. So for this, I'm going to create another data frame. Let's say raw data, raw df equals to spark dot read format dot format, and this format is going to be a binary, right? Binary file load from base path, that is the volume path, and let's simply display the raw df. Let's run this now. So we have path, modification time, length, and here you'll see we have a content. Now right now this content is in a gibberish format because our file format is in PDF and not regular CSV or JSON data, as I said. So what we are going to do, we are going to parse this content using AI parse document function. So let's do that. This step is going to be the most important step in our entire project. So here what I have done is this. I have simply passed that content, that is a binary content that we have in the content column, to the AI parse document function. And I've simply created a new data frame, df parsed, on top of that raw data frame. And I'm simply displaying the 3 rows of that new data frame that we have created, that is df parsed. So let's run this cell. In the output, notice the data type of the parsed document column. It is of variant type, which is Databricks special data type for deeply nested structure. So, which is similar to the JSON object. And if I expand this, you will notice that nested structure I'm talking about. Okay. It is similar to a JSON string only. If you look at this elements now, so it is going to look like a JSON structure only, but it is now of type variant. And as I said, that AI parse document function is going to break your entire document into the sequence of elements. Okay, for PDF number 13 of property damage claims, we see that the first element is a safeguard insurance scope as a content, which is of type title. The second element is a property damage claim form, which is of type text, and so on, right? So every element here, you notice, has the same structure, that is the same schema, right? First we need to extract the element array, because our entire data, the information that we need to extract, is present in this elements only. So we need to extract the elements array from inside this document. Okay, and what we are going to do, we are going to simply convert it to a plain string, so that we can apply the functions that are Spark's standard functions, like from JSON and explode, that I'm going to show you in the next step only. Okay, so to do this, we'll be using a variant get function with a along with the JSON path to navigate inside that variant. Okay, so to do this, I have written this code. Okay, so I have created a new data frame on top of that df passed. Okay, so here I have used a variant get function in which I have passed that variant data type column parse document, and here we are saying, okay, go to that document and go to that elements. This is where our elements array lies, and what we are saying, we are simply saying that cast it to the string and give the name to the column as a element JSON. So let's run this, and I'm simply displaying the that element JSON data frame. Okay, in the output, you notice we went from complex nested variant to a clean JSON array string. So on this JSON string that we get here, we can apply those standard Spark functions like from JSON and explode. So let's do that. For this, I have written a code something like this. Okay, first of all, I have defined a schema of that elements. So as I said, every element has a same structure, so it has fields like bbox, content, description, id, and type. Okay, so that's what I have defined here with the element schema for that all the elements that we have. So it is of type array of struct, which has an id, which has fields like id of integer type, type of type string, content of type string, page id of type integer, bbox of type struct, of coordinates array of integer, page id of integer type, and description of string type. So this is the standard element schema that I have provided here explicitly. So in this, I have created a new data frame elements df on top of that element JSON df. So here what I have done, so I pass that schema to the from JSON function, okay, on top of that element JSON column that we have here. So what this does is, for each element in the JSON, it parse the data according to the defined schema. Okay, and create a corresponding columns like id, type, content, page id, based on the structure that we have defined in this schema. Now since we are dealing with an array of those elements and not a single element, so what I used explode function. So the purpose of this using an explode function is to flatten that array. That is simply means it will create a separate row for each element present in that array, because every element follows the defined schema. So every explode row will contain the same structure column derived from that schema. And I'm simply here rename the columns, that id to element id, type to element type, content to content, and description to description, and simply displaying the newly created elements df. So let's run this cell. So once we run this cell, you will notice in the output that we get around 20 to 25 rows for each pdf, with each element contributing to one row. So as you notice, we have around 50 rows and we have a array of those elements. Now what we have a around, for property damage claims file number 13, we have around 24 rows. Okay, so and we end up getting around 1134 rows for those 50 pdfs that we have. Okay, so we have columns like element id, element type, content, page id, bbox, and description that we get from JSON and explode. So just like that, we transform the nested JSON into fully structured and analysis ready format. Okay, so we cannot completely say it's an analysis ready format, but it is. Okay, So while exploring this output, I noticed one thing. So we are interested in the uh, breakdown that is present at the element id 11, which is of element type table, in which we found the property damage claims breakdown. Then second thing, total claim amount. Here you notice the total claim amount is in the another row, and the amount associated with it is in the another row. So AI pass document had split the total claim amount into two separate rows. Now this is a problem. So because we are going to use a regular expression, which we are going to write it later part, so that needs to find total claim amount and the amount associated with in the same string. So if they are in the separate rows, the regular expression will never find that amount, and every claim PDF would came back with an empty total. So we need to fix this. If we look at the other PDFs, so let's take an PDF from the health document. Okay, so PDF number 9, and if I go here, okay, so here also you notice we have a total claim amount and the amount associated with it in the uh, two separate rows. So the solution that I have done for this, or the fix I have done for this, is the I have used the Windows function, and that Windows function is obviously going to be a lead. So, and for this I have written this code. So lead is the Windows function, right? That lets us look at the next row's value while we are processing the current row, right? So when we find a section header of total claim amount, we look at the next row using the lead, which is where our uh, value about the amount lies, right? So what we are going to do, we're going to grab that content that is of text type, and we are going to merge them into one string, that is into the section header string only. Okay, so if we do this, we end up having this row as well, right? It's going to be redundant, so we are going to use lag to remove that redundant row. So this is what I have done in the code I have written here. Okay, first of all, I have partitioned the data above data frame based on the path column and ordered it on the element id. So here I have used that lead function, in which we are taking the content and element type plus one, right? So we are looking for the this amount, and here I have applied the case statement, which is checking if the row is the section header with the text total claim amount, and the next row contains the amount, which is example rupees something. Okay, so what we are going to do, if we found that, so we are going to merge those both the rows into a single row and keep all other rows as it is. So that's what I have done. Have used concat ws, that is concat function, to merge that content. And as I said, we end up getting the redundant row of that value of the rupees, that is amount, right? So we simply drop that uh, row every time we merge the two rows. Okay, so that's what I have done. Let's run this cell and let's check out the output. Okay, so the output we're going to see is in the form of element df clean. This is the new data frame I have created. So let's display elements df clean, and let's run this cell. Okay, in this data frame our clean and fixed data frame lies. Okay, so we don't have a two separate rays for the total claim amount. For the auto claim file number 8, we have the total claim amount and the amount associated with in the same row, and the redundant row, that is the element id 13, is removed, that we can see here. Okay, let's go for the health also. Okay, so here also you see the total claim amount and the amount associated with it is in the same row. So the fix that we used using lead and lag functions, that worked. So the elements df clean data frame has about 1000 plus rows, but honestly most of these rows we don't care about at all. The content like company name, the claim type, and others information like claimant information, we don't really need it. We only want rows that contains the financial information, right? That is the breakdown, the claim amount, and the claim status. For this, what I have done, I have created the list of keywords, like common keywords that are present in every claims document, then respective claims breakdown keywords we want to extract from all PDFs. So for this, I have created the list of keywords. like this. Okay, so here I have created the list of keywords. The common keywords are total claim amount and claim status that you will find in every claims document that we have. For automobile claim insurance, these are the keywords that we have. The health insurance, we have this much keywords, and the property damage claims documents that we have these many different keywords that we are interested. These are the breakdown keywords. Using this list of keywords that I have created here, so we'll simply filter out the rows where these keywords are present. Okay, so for this I have written a logic something like this, created a new data frame on out of that claim elements clean data frame. Okay, so first I created a new content here column where I simply lowercase the content that are present in our content column, so that when we match the keywords present in the list of keywords, we'll find the exact match. And then I have applied the list comprehension on the where clause. Okay, this is where we are matching the keywords from list in newly created lowercase content el column. Okay, it will simply going to match it like content el, the where we lowercase the all the content that we have present in a content column. So it will go to every row in the content el column, and there it will do like a where condition, like total claim amount that we usually do with the SQL queries. So that's how it is going to fetch the required rows. Okay, let's run this cell. Sorry, before that I have to run this keywords list of keywords and then run this cell. Now look at the output. For each PDF, we end up getting three rows: the breakdown table, the total claim amount, and the claim status. But here you'll notice in the table, we have these element tags like table, tr, td present in every PDF that we have, right? So first of all, we need to get rid of this so that we can make a use of regular expression to get the breakdown amount associated with the keywords that we have defined here, right? As I said, first thing we are going to do, we are simply going to get rid of this HTML tags. For this, what I have done, I have simply written a code something like this. I have simply created a new data frame, pairs src. On top of that, above created data frame, claim amount candidates. Here, what I have done, okay, I'm using the regular expressions here. So here, if you see, we have a content column here. We are simply saying wherever you find these arrows, like this arrow in which we have table, in which we have tr, in which we have td. So wherever you find these arrows, no thing, we simply saying remove these tags and the content inside it and replace it with the space. The next thing what we are doing on the same content, we are saying once you remove that, there are going to be lots of spaces. Collapse those multiple spaces to one. In the end, I've created the uh, claim type column to identify which claim type we have for this particular uh, PDF. Okay, so that present in the path. Okay, so that I was simply selecting the, if there is auto present in this path, it's going to be of claim type auto. If there is HLTH present in that path, it's going to be of type health. And similarly for the property damage claim, otherwise consider it unknown. Okay, that's what I have done. So let's run this cell. So let's display the result. Look at the output now. Notice the difference between the content column and the plain column that we have. Okay, here you notice we have the HTML tags, right? And here you will see we removed these HTML tags. And if you look at the plain yell column, what I've simply done, I've simply lowercase all the information that we have in the plain column. Okay, so that's what I have done here. That's it. Okay, I forgot to mention in plain yell, here you'll notice I have simply used the lowercase. Now we have a clean plain text. So on top of it, we can apply the regular expression, okay, in order to fetch the breakdown, the total claim amount, and the claim status. And additionally, we now know its claim type. Before going forward, let's revisit what we have done till now. We started with the raw PDF documents in a binary format. Using AI parse document function, we parse the binary content and we end up getting variant data type, which is a Databricks special data type, which gives us structured access to the document content. From there, we navigated into the elements and extracted elements using variant get method. We end up getting an array of JSON string, and then we define the element schema on top of the element structure that we have, and that schema we pass to the from JSON function, and on top of that we used explode as we have the array of elements there. We end up getting the multiple rows, around 20 to 25 rows per claims PDF with elements fields as columns. There we encounter our first problem where the total claim amount and the amount associated with it were in the two separate rows. We simply merged these two rows and removed the redundant rows using lead and lag Windows functions. And as we only require the information like breakdown, total claim amount, and the claim status, we end up removing other rows as well. With the help of the list of keywords we define by simply matching it with the rows contains these keywords or not. Then we remove the HTML tags and extra spaces and save the content as a plain text. So at this stage, each PDF was reduced to 3 meaningful rows containing all required information. Now, if I apply a regular expression on top of this plain text that we have in this plain column, we end up getting the 3 rows, in which first row is going to be a breakdown values in one row, then the total claim amount and the claim status, right? But we don't want it in this way, as we have to apply validation like whether the sum of these values or the amount present in for this breakdown is equal to the total claim amount or not. So before that, let me show you what problem we encounter there. So let me quickly show it to you. Okay, so first of all, I have filtered the whatever we have in the pairs SRC data frame to the automobiles claims document only, and I have passed that to the new data frame AutoDF, where I used select. I'm selecting only path and the claim type, and you will notice I have applied that regular expression for vehicle body repair, the space part, towing, surveyor, total claim amount, and the claim status. Let me run this cell first. Okay, if you notice for the claims documents of automobile for PDF number 7, we end up getting 3 rows. In first row, we have all the values for the repair, vehicle repair, right? The breakdown values. Then in second row, we have total claim amount, and in the third row, we have the claim status. We don't want it this way, right? We want all the values reflected in the single row. For that, what I have thought is instead of applying regular expression on a multiple rows per document, we can simplify the structure. So what I have done is this. I simply group the data by path and the claim type that we have and applied the aggregation. So I aggregated the rows into the list. Okay, so these 3 rows into a list, and I simply concatenated them into a single merge text column as a full text. So let's run this cell. So it will give us 1 row per PDF, that is the path, and all relevant information in 1 row cell only. Okay, so here you'll notice we have all the information, the breakdown, the claim amount, and the claim status in the one cell of that for that particular PDF. So in the output, now we have 50 PDFs, right? For that we have 50 rows, each containing the complete claim information that we required. Step is going to be the key step. Here we are going to extract values in structured format using regular expressions. Since each claim type like automobile, health, and property damage has different breakdown values, right? And formats. What I have decided is first we are going to filter the data by claim types. Okay, We are going to create a data frame for automobile, for health, and for property damage claims. Then we are going to apply the regular expression separately for each claim types and as per the breakdowns that we have. And at last, I'm going to combine all three types of claims data frame that we have using union by name. So that's the plan. First, we are going to filter it for the automobile claims that I have done using the filter function. We are simply filtering for the automobile claim and created the auto level data frame. Simply created a new auto level data frame on top of that auto level data frame. Okay. So here I use select, in that we have path, claim type, and here I'm using the regular expression. Here we are extracted the breakdown fields for the automobile, vehicle, body repair, the spare part, two-wheelers that are present in the automobile claims document. Okay. And the amount associated with the each claim document that we have. So, and then the total claim amount and the claim status. Here, each breakdown is going to be a column and the extracted values going to be populated in the rows. That is the amount values. And for the claim status, I have used enum here that has only valid status values. So here we are simply ignoring the unwanted noise or extra text that I encountered while going through the documents. Because this regular expression that I've written for the claims document, no, in order to fetch the claim status, it is not working for the automobile claims document as expected. So that's why I have hard coded the values here using enum. So let's run this cell, and meanwhile I'm going to explain you, okay, how this select is creating the columns for us, right? So think of select like this. So it is going to give us a new data frame with these columns like vehicle repair, spares part, towing charges, survey fee, total claim amount, and the claim status. And it is saying I'll define how each column should be computed, right? So each argument inside the select act as a column expression here. So this two going to act as a simply the way we use in the select statement, and this is where the things changes. Okay, let me explain it to you. Here what happens is Spark read the full text column, applies the regular expression vehicle body repair dot stars question mark rupees and all. Okay, so here if you notice I have created a group which is a group of amount which is present after the rupees, right? Present after the rupees. So I have created a group of this and we are only extracting that group for that column that we are creating, vehicle repair. Okay, similar way we are doing it for the spare parts, towing charges, survey fee, total claim amount, and the claim status. We are extracting the group. So this is how every, let me run this cell. So this is how every column defined here becomes a new column in the output data frame. Okay. And look at this output now. It looks perfect. We are able to get the amounts correctly, and I have already cross-checked it with the documents that I have. Okay, and if we have a wrong or mismatch value, we are going to validate in a validate step in the next few minutes. Okay, I have applied the similar approach or the same approach to the health claims document and the property damage claims that we have. Okay, so let me quickly show it to you, the code that I have written. Okay, let's run this for health data frame. Okay, I have simply filtered it for the health, and similar logic, similar functions, similar regular expression I have used with this. Okay, this little change in the room charges, I have applied a little different regular expression here because we are getting there two different rupees values there. So room charges includes the charges in rupees per night. So we are not interested in per night. We are interested in the full value associated with. So that's why a little change in this. Otherwise you will see all the regular expression are going to be the same. Just the breakdown value or the keywords is going to change. Otherwise in every whether it's automobile or health or medical, the same regular expression we are using. Okay, till total claim amount. And for the claim status, if you notice here, I have used this regular expression. Okay, that's it. And I already run this cell. For health also, we got all the values correctly. If we look for the ICU charge here, we are end up getting the blank value. Okay, so we need to handle this as well. Okay, we are successfully populated the all the amount values and the claim status. Okay, let's do it for the property damage claims document that we have, and I've written the code. Let's run this cell. So here also we use the same pattern, applied the claim specific regular expression. Here the keywords are like structure damage, machinery damage, stock loss, electrical. Okay, and common are the total claim amount and the claim status. Nothing new in the logic, just adapting the regular expression to match the claim type structure. That's what we have done. Okay, for this also we are successfully extracted all the required values. Now we have all required data in the structure format for all claim types in the three separate data frames: auto df, property df, health df. Each has different columns as per the breakdown field. We need to combine all three data frames into one table. So let's merge it together. For this, we can make a use of unionByName function. So let me show it to you. Yeah. Okay. Here I combined the AutoDF, HealthDF, and PropertyDF using unionByName function and saved it as a claim combined data frame. So union by name is going to stack the data frames on top of each other by the column name and not by the position. Okay. So, and the argument allow missing column, I have set it to true. That is, if the column exists in one data frame but not in the other, so it automatically gets filled with the null values. Okay, let's run this cell. See in the output, we have claim type, auto, property damage, and health. Okay, all three types of data that we have together in the combined df, combined claim combined df. Okay, so we have automobile claims, all the values populated correctly, the claim status and total claim amount. And if we look for the values for room charges, ot fees, anesthesia, and for the stock loss, electric, it gets filled with the null because this value is not present in the automobile, right? So if we go for health, right, you will see that these values get filled now and these values are filled with nulls. Similarly for the property damage claims. So this is how union by name is going to merge all three data frames that we have. Okay, this I have done intentionally, so we end up getting the 50 rows in one table and for all three claims types together, and nulls are populated exactly where they should be. And we are almost at the finish line. Two final things we left to do. First, we need to convert all this data that we have. No, if you notice, we have this in the string format. So we need to convert it to the actual amount, that is to actual numbers, right? So we need to cast it to the double. For this, what I have done is I created a one function to number. Okay, and two things this function does: if the value is an empty string, it returns null. If you remember, we encountered for the health or medical damage claims, there is a one value missing for the ICU charges. No, so in that case, we end up getting the blank space. We are replacing that with the null. And if the value has the comma, if you notice, we every value here has the comma in it. So we need to convert it to the doubles. We need to get rid of this comma. So that's what I have done using regular expression replace, and then simply casted it to the double. And now we are going to apply this function to every single column that we have in the above data frame, that is the claim combined. Okay, okay, here what I have done is I created a new data frame, claim gold, on top of that claim combined data frame. Here I applied the toNum function that we defined here, no, the helper function, to all the breakdown columns we have, right? Vehicle, repair, spares, part, all for the automobile, health, and for the uh, property damage claims, except the claim status. And now the second thing, of the two things I have talked about, we are simply validating the data. Okay, so what we are doing here, we are calculated the calculated total column. Okay, so for what, in order to see if the sum of the breakdown fields as per the claim type. Okay, so we are doing summation here, that matches or not with the extracted total claim amount. Okay, so is that matches with this total claim amount or not, that I have done here. Okay, for this I've created this calculator total column using the case when statement. Okay, that says if the claim type is of type auto, then do the summation of these fields. And if it's of type health, do the summation of these fields. Otherwise, do the summation of these fields. And if you notice here, I used the coalesce function here. If the field is null, by chance we end up getting this field as null, we need to handle it, right? So we are setting that value to the 0, so that when we do the summation, no, so we not end up getting the null value in the output. Because if you do null plus any number, we end up getting the null values. So entire calculator total columns becomes the null. So to handle this, I use the coalesce function here. So here I calculated the difference by simply subtracting the calculated total from the total claim amount. We'll get the difference. And here I have said created a new column is consistent, which is checking if the difference is it less than or equal to 1, that is under 1 rupee or not. If it is, the data is clean. So I have kept the 1 rupee tolerance because when you add 4 to 6 large numbers, floating point arithmetic can give you a tiny precision error like 0.601. So 1 rupee tolerance handle that safely. So that's why I've given the 1 rupee tolerance here. Apart from this, I've created the status flag column. So what we are doing here, so we are created a flag columns like flag values like missing total if the total claim amount is null. Means when we extracted the total claim amount from the document, no, we end up getting the null value. So that is highlighted by the flag missing total. And if we gets any kind of error when calculating the total, uh, that is, we found that okay, it's null, so there is something missing, right? So we flagged it as a extraction failed. And if the is consistent is false, no, so we are saying that okay, I'll flag it as a total mismatch. Otherwise, flag is that everything is okay. Okay, that's it. And here I've simply mapped the claim type to descriptive labels like auto to auto, accident, health to health, or medical, and property prop to property damage. And then finally, I've simply extracted the file name from the path using this regular expression. If you notice, I have created a group here. So let me run this cell and I'll walk you through the output. To num is not defined. Okay, we forgot to run the cell. Yeah, let's run this cell. That means we need to first define the to num function, then run this cell. Okay, so it's now going to run. Okay, so we have all the required data. So we have path that is not required. Okay, the claim type. Now look at this data type. It is populated correctly to the double. Okay, and we have claim status, total claim amount. Okay, let's go for the validations. Okay, so the calculated total is this much, and the difference we found is 0. Let's look if there is anything wrong in it. No. So the consistent column is always true, going to be true for our documents data that we have, and the status is okay. And if there is something wrong, no, though, that we can get to know in the status and in the consistent column, and we'll get to know the difference between the calculated total and the total actual total claim amount that we have on the document. And this is the file name. We are simply selecting the last part of it. Okay, so that's it. So now we are able to extract the right numbers. The numbers adds up correctly and the data is validated. As we have this file name present in our final data frame, we don't really require this long file path name. So let's drop this let's drop this path column first. Okay, so for I'm simply dropping here the column path from this claim gold. Meanwhile it runs. So the final step we are left with is we need to create a gold schema, and we are going to create a gold table in it. That is going to be a managed delta table on top of that validated data frame that we have as a claim gold. Okay, so as you can see, the path column is dropped. This is our validated final data frame. So let's first of all create the schema. Okay, so I'm using Spark SQL. Here I created a gold schema in that safeguard insurance catalog that we have. So let's run this cell. Meanwhile, I'll open this catalog. Okay, so we have a safeguard insurance. Yeah, it's created this gold schema. Now you can see we have a gold schema. Currently we don't have any table present in it, so let's create that gold table. Yeah, so I'm simply created that claims gold table in the gold schema of that Unity catalog safeguard insurance with the mode override. On top of that, final data frame that we have claims gold. Okay, so the names are kind of similar. Let's run this cell. So what happens after I run this cell is the table that is a claims gold delta table, that is managed delta table, is going to get registered in this Unity catalog safeguard insurance. Okay. Yeah, now it's completed. Let's refresh this catalog. Go to safeguard insurance gold. Now we have this delta table claims gold. Okay, and we have these fields in it. So our gold table is ready with 50 rows, and everything is validated. So let's quickly cross check it if we successfully loaded the data. Okay, so let's run the query. Safeguard insurance table count. We are simply counting that. Okay, yeah, it's there are 50 rows in it. Now now let me show you something really cool that we left in this particular project is working with Genie. So what we are going to do, we are going to connect this delta table claims code to a Genie, and setting it up is super simple. Okay, let's do that quickly. So here on the left hand side you see the Genie. Click on this. I'll open it in the new tab. Okay, here you will get a option to create a new space. Okay, so click on it, select all, go to the catalog. In that we have a gold schema where we have this gold table. So click on create. Okay, so it's created a space for us. Okay, and here you can give this namespace. Okay, it is starting the warehouse. Till then, let's give the namespace safeguard GUARD insurance claims. Okay, safeguard insurance claims. So let's save this. Yeah, here we get to see the name. Now here is where things get interesting. So the Genie going to convert our English questions that we are going to ask here into a SQL queries. So it is going to run them on our goal table that we have attached. Okay, and it will return us the answer. Okay, so that answer is going to be interesting. I'll explain when we get the answers. Okay, so imagine you're a reporting manager with no SQL knowledge or technical knowledge. Uh, can use this Genie space to get the answers by simply typing the questions in a simple plain English. So let me show it to you. Okay, so the first question I'm going to ask to the Genie is, so what is the total claim amount for each claim type? Okay, so let's ask this question and click on the send button. Okay, so it's get submitted. Okay, now it's thinking. So it's working behind the scene. What we did, we simply asked the questions, and behind the scene it is doing the things. We need to wait for a while. That's it. Now we get the answer. Okay, here notice what we get in the output. Okay, we get some description with the explanation, and along with that we get the a bar chart that is a visual representation of the question that we asked. And here we do not specifically mention we need to see the bar chart. It generated it for our better understanding. So if you see, we have a property damage, health and medical, and the automobile claims and their total amounts. So here is the description: the total claim amount by claim type. The property claim damage claims account for 51 millions and representing 97% of the total claim amounts. And here is the breakdown in the table format. And if you want to see the SQL query it had generated, so click on this, you will get to see the SQL query, and click on the show code, you will get to see the SQL query. You can cross check if it has done the correct way. Now let's move ahead and try the second question. So the second question I have is this: how many claims have settled by each claim type? So I'll quickly copy paste that question here, and let's now ask the question. Okay, so it is processing, that is submitting the query, it is now thinking. Okay, the settled claims by the claim type. So there are 10 claims have been settled across all claims types. Health medical leads to 5 settlement, followed by auto accidental 3, and the property damage claims are 2. Okay, so this is what we get. Thinking completed, we got the answer in the output. Okay, so the here I am not able to see the source code it had generated, all of those things. I don't know why, but let's move ahead and ask the third question that I have. We can ask here is, which claim type has the highest average payout? Okay, so this is going to be a little difficult question for the Genie. So let's see how it handles it. So this is where our table that we used for the Genie workspace, Genie space here. So it has completed the thinking and it has generated the answer for us. Okay, so the highest average payout by claim type. So the property damage has the highest average payout of 3.2 million dollars, which has 35% times, okay, 35 times higher than the health or medical, which is of 90K, and 49 times higher than the auto accidental, which is of 65K. And this is the breakdown that we get. And here you see the source in which you could find the SQL query. Okay, it has we only asked for the average payout, so it, along with it generated the minimum and the maximum. So it has given us the extra information that we actually didn't ask, but it is very useful for the reporting manager. Okay, so it has given some comparison for the different claim steps that we have. Okay, so that's it all about this project. I hope you enjoyed, and thanks for being till the end. And if you like this video, please give it a like and subscribe to my YouTube channel, and I'll see you in the next video. Till then, take care. Bye bye.